Lesson 6 Part 2 InterVLAN Routing. In this video lesson, guys, we'll take a look with you how we can make how computers can make communication if they are placed on different VLANs. So to be able to have the connectivity between different VLANs, we have to have at least one equipment which is working on layer 3. It can be a router. So that in our topology we have PC1 which is placed on VLAN 10 and PC3 which is placed on VLAN 30. And to have communication between each other, we place it here router, so that our switch ports, so let me draw here with red colored marker. So red colored marker ports on the switch are going to be configured with the VLAN 10. And blue colored ports of the switch will be configured with VLAN 30. And now we have to make also configuration of our router, so that we are able to configure an IP address, for example 172.1.7.30 and 1 here. And from the other side, we can make configuration of our port with an IP address of VLAN 10. It's going to be 172.1.7.10 and 21. I'm sorry, not 21, it's going to be 1. So that, and our computers will be configured with these IP addresses, and additionally we'll provide the subnet mask. For example, it's going to be subnet mask of prefix 24. And then we'll provide information about the gateway, and the gateway can have to be 10 and 1. It's going to be IP address of our router's interface gigabit 00. So that after we made up these configurations, we'll just take a look for the routing table by using command show IP route, and we'll see with you do directly connected networks. They are going to be 172.1.7.10, 0 and 172.1.7 and 30 0 with prefixes of with prefix 24. So that when packet will be directed from PC1 to PC3, we will not be able to communicate like this. We have to send information to our default gateway. Why? Because our destination IP address is placed on different network. And that is why we'll use the service of the router. Router will deliver this request, will define to which it will define that it has connectivity with this network, and afterward, by the way, I forget to draw here the exit interfaces, and our router will define that, alright, I will resend this information through gigabit 01 interface, so that we'll have here a hop, and then our communication will go to PC3. When PC3 will give reply will come in vice versa. It will come to the router, and then router will analyze the destination IP address, and it will find out that this packet goes to network 10.0, which is connected through gigabit 00 interface, and here we'll have a hop, vice versa hop, and our information will reach the PC1. So that so let me say that all these ports, guys, are going to be configured as the switch port mode access ports. So 2 of them will be configured as VLAN 30 and 2 of them will be configured as VLAN 10. So we don't have any trunk element in this topology, and we have just only configuration of gigabit 00 and gigabit 01 interfaces on our router 1. So that let's switch to our topology. Maybe it is a little bit different, I mean, with the IP addressings. So we have with you pre-configured switch 0. So PC2 is part of VLAN 10, and laptop 1 is the part of actually VLAN 10. Sorry, so I have to change it to 20. So that I will change an IP address firstly. Let me change it here in the configurations. So the IP address of this equipment is going to be 20.10, for example, and its default gateway is going to be 20.1, whereas PC0 is going to have an IP address 10.10 and its default gateway is 10.1. Now it's time to take a look what do we have in pre-configuration of switch of the VLAN. So I have to analyze that the port FA04 to which VLAN it is belonging. It belongs to VLAN 10, so I have to change it to VLAN 20. Let me do it. Interface FA04 switch port access VLAN 20. Do show interface, do show VLAN. Command will show me that my port FA04 is now placed on VLAN 20 and my port FA01 on the switch is placed on VLAN 10 here. And now it's time to make connection between switch and the router. And to do this connection I have to use trace row cable, and I will select those interfaces which I didn't use before in this topology. It's going to be FA11 2 gigabit 00 and let me write here a note that is going to be FA011, and here we'll have gigabit 00 interface. And our second connectivity will be FA012 2 gigabit 01 interface, so that I will also write here some nodes like FA012 and gigabit 01 interface. So that, look guys, we will have with you IP addresses like 192.168.10.1 with prefix 24 on gigabit 00 interface. It will be connect the VLAN 10, and here we'll have with you IP address 192.168.20.1 with prefix 24. So that it's time to make configuration of these two interfaces on the router. First, I have to start from the turning on my interfaces by using command no shutdown, and then I will make configuration of my interface with IP address. So that an IP address is going to be 192.168.10.1 with subnet mask of prefix 24. And interface gigabit 01 also have to be turned on, and then it have to be configured with IP address 192.168.20.1 with subnet mask of prefix 24. And then I have to take a look for my routing table, which is showing me that I have two networks connected to this router. They are 192.168.10.0 and 192.168.20.0, which are connected through gigabit 00 and 01 respectively. Now it's time to make configuration of my switch ports, so that I will assign interface FA011 into the mode access and switch port access VLAN 10, and interface FA012 will be assigned to mode access and switch port access VLAN 20. And if I'll take a look for my VLAN table, I will see that I have new ports that are members of VLAN 10 and VLAN 20. So that FA011 port belongs to VLAN 10 and FA012 port belongs to VLAN 20. And now it's time to check the connectivity between these two computers, which are placed on different networks. So that we have to send information from PC 0 to laptop 1. So in the same way, I can see here ARP and ICMP protocols messages. So my ping is going, but before sending the ICMP message, our computer will try to find the MAC address of the default gateway. And why our computer is searching for the MAC address of default gateway? Because so PC0 understands that the destination IP address is quite on different different network than its own IP address. That is why it is making decision to find out the default gateway, and default gateway have to help the computer to reach the destination. So that ARP message is generated, and as you know, this is the broadcast communication, but due to that fact that our two ports belong to VLAN 10, information will go only through FA011 port to router, and router gives reply with its MAC address, and then our computer will send an ICMP message. This is actually our ping, and then our router will generate an ARP message also to find out the destination's MAC address, because router didn't know about MAC address of laptop 1, so that is why it is searching for its MAC address. And it's also broadcast communication, and so because of it, we lost our packet. You see that our status of the test is failed, and when we'll do the same test next time, so we don't have to have problems with the ARP, so that our equipments already know about MAC addresses of their destinations, and our communication will be done like this. So that if you have the network in which you have 3, 5, or maybe 40 VLANs, then you have to have connectivity to your router, and for each VLAN you have to create the link so that each interface of the router will be placed on different network. This is one type of the InterVLAN routing. It is called the traditional InterVLAN routing. But in case when you want to save your links, I mean, if you want to save your ports of the switch and the router, due to that fact that you have a lot of VLANs and you are not able to spend all of your links only to make InterVLAN routing, so then you can use the InterVLAN routing, which is called, so I don't have here the slide of our previous example, but I can just explain it here. So we may have with you situation that we have a lot of VLANs. We don't want to use multiple links between switch and the router. So that why don't we use a single link? So let's say that this is single link. It's going to be gigabit 00 and FA011 as in our example. And let's say that this link is going to be configured as a trunk link. So that on our port FA011, we'll type the command like switch port mode trunk, and this will be quite enough for us. So we just type here on the switch port mode trunk, and that's it. And it becomes to work as a trunk, and it will allow to communicate for all VLANs through this switch port. And we have some changes on our gigabit 00 interface. Due to that fact that this is single interface, we have to have, due to that fact that this is single physical interface, we have to create a logical sub-interfaces of this interface. So that we can create this logical sub-interfaces by using commands or like interface gigabit 00. Firstly, we have to go to gigabit 00 interface, then we have to turn it on by using no shutdown command, and then we have to go to make configuration of interface gigabit 00 dot and any number. So we have a lot of numbers. It's like more than 2 million numbers are available in when you are creating the sub interfaces. So that, for example, if we work with VLAN 10, so we can select number 10, dot and number 10. But this value is not mandatory that it will be the same value as your VLAN ID. But it is like, it's our choice. You can select any other number. And after what, you have to make such kind of configuration of your interface, like encapsulation .1q, whereas .1q is the, so our trunk has the standard, like an Ethernet frame got standard 802.3, the trunk got the standard 802.1q, which we saw with you on previous lesson when we had target frames. So that 802.1q describes the trunk. And when we want to make configuration of our router's interface, we have to make configuration of this sub-interfaces so that they will work as a trunk by using this command, encapsulation dot 1q, whereas dot is this dot and 1q. So this is actually the command which makes from the subinterface of the router as a trunk, so the VLAN trunk. And then we have to define that this subinterface will work with VLAN 10, and here we have to type a VLAN ID. So this is mandatory that it will be same value as your VLAN ID. Alright, so if you want to work with VLAN 10, then you type VLAN 10. And afterward we have to go to interface gigabit 00 dot, so this is 00 dot 20, for example 20, it can be different value. And then we have to type command encapsulation also dot 1q and then 20. Oh, by the way, guys, I forget to tell you that we have to also give an IP address for the subinterface. So we have to give IP address by using basic address configuration, IP address, and then, for example, 172.168.10 and 1. And then we'll also provide an IP address here. It's going to be 20 or like 30.1 in this example with the subnet mask. So let's try to make these changes on our topology, so that I will delete these two links, or maybe, yeah, alright, so I deleted these two links, and now I have to make configuration of my switch port, so that I have to say to interface FA011 no switch port mode access and switch port mode trunk. And then I have to make configuration of my subinterfaces. But before, I have to delete my IP addresses from both of the interfaces, because I will have the duplicated IP addresses on different interfaces. No IP address command and interface gigabit 01 no IP address. Do show IP interface brief command will show me that I have no IP address assigned to all of these interfaces. Okay, and now I have to make configuration of gigabit 00. So I will type no shutdown command, but actually it's already turned on. But imagine that it was turned off. And then I'm typing the command interface gigabit 00.10. This is going to be this command will create subinterface, and then we will type the command encapsulation.1q, which will work with VLAN 10. And afterward, only afterward, I'm able to type an IP address 192.168.10.1 with subnet mask of prefix 24, and interface gigabit 00.20 encapsulation .1q, and it will work with VLAN 20. And then my IP address command will be written like this: 20.1 with subnet mask of prefix 24. Now, if we'll take a look for our IP table in brief, so we can see that we created two subinterfaces, gigabit 00.10, gigabit 00.20 with these IP addresses. If you'll take a look for your routing table only for connected networks, you will see that you have same networks as you had before, but their connectivities to interfaces are quite different. So you use actually a single physical interface, but this single physical interface has two sub-interfaces. And now when our computers will try to make communication with each other, they will make communication through our router. So let's examine it. Well, something went wrong. So let me go to the real-time mode and let me fast and forward time so that the process will of the conversions will be finished. And now we are going to send information from PC 0 to laptop 1, and it goes to the router sub-interface gigabit 0010. And after what, our router search for the MAC address of laptop 1, because it already forgets about that MAC address due to that fact that ARP table got its aging time. And this is request, this is reply, and then if we'll make a ping from PC0 to laptop 1 more time, so it have to be successfully be delivered. So look, our switch sends information by trunk, and before it will send it by trunk. We'll examine our frame, and this is our frame, Ethernet 2 frame, which has source and destination MAC address, which doesn't have any tags. And then when our frame will be sent from switch to router, we'll take a look for our frame. It have to be tagged, and as you see, Ethernet 802.1q type of the frame, which is tagged with the VLAN ID. And then it is entering to gigabit 00 .10 subinterface, and it is exiting the router through gigabit 00.20 subinterface, like this. And our communication will be happening like this. So this type of InterVLAN routing, guys, is called Router-on-Stick. You see, like router and stick. And you can make InterVLAN routing for multiple VLANs. It can be 40, 50, or 100 VLANs. And you will save your resources of the switch ports and the router interfaces. But when you are using Router-on-Stick type of InterVLAN routing, your speed will be impacted negatively, so that you have to understand the situation. Well, this is actually the end of this lesson. I hope that this lesson been informative for you. We'll also work with VLANs when we'll work with the ACL, access control list, and also when we'll work with the dynamic host configuration protocol. And see you again, guys.